Okay, to solve this problem, let's just first draw the circuit diagram. It will make things very easier. So here we know that it is a series circuit containing an electric lamp and a conductor of 5 ohms. So let's just draw that. So there is an electric lamp and a conductor of 5 ohms. That conductor, I'm drawing it like this as a resistance. Then there is a battery of 10 volts. So this is 10 volts, this is 5 ohm, and this is the lamp. And what else do we know? We know that the current in the circuit is 1 ampere. So this 1 ampere, it flows through both bulb and the conductor. And why? Because it is connected in series. Now what we have to find out? We have to find out resistance of this electric lamp. Okay, we know the resistance of this. We have to find the resistance of this. Now from Ohm's law, we know that V is equal to IR. Now if you just rearranged it in such a way that R is on one side and everything else is on the other side, we'll get R is equal to V by I. Now V, we know that it is 10 volts, but what about I? I is nothing but 1 ampere. So I is equal to 1 ampere. So hence the total resistance of this circuit is 10 ohms. So what is 10 ohms? It is the effective resistance of these both resistors. Okay, that is 10 ohms. If this is already 5 ohms, then what should be added to 5 ohms to make the total resistance as 10 ohms? Yes, so this should also be 5 ohms. So hence resistance of the electric lamp will be 5 ohms. Now let's look at the second part of the question. Now if a resistance of 10 ohm is connected in parallel with this series combination, let's draw that. So in the second part of the question, everything is the same. There's just one change. A resistance of 10 ohm, resistance of 10 ohm, this is 5 ohm, this is 5 ohm. Resistance of 10 ohm is connected in parallel with the series combination. Just draw the battery. Okay. What change, if any, in current flowing through the 5 ohm conductor and the potential difference across the lamp will take place? So they're asking, is there any change in current flowing through this 5 ohm conductor? And is there any change in the potential difference across the lamp? Okay. So to understand that, we know that initially the current passing through this is 1 ampere. But now what happens? The current comes here in this circuit and then it divides into two different currents. Okay, so the current gets distributed. So this is the key learning for this question. Current gets distributed in a parallel circuit. Okay, and so let's try to find out what's the current flowing through this and this. Now in order to find the current flowing through this one, we need to find out from the Ohm's law again, V is equal to V by R. Now, what is V across these 2 points? The V across these 2 points is same here. I'll just write it here. It is 10 volts. So the V across these 2 points is nothing but 10 volts. And what is the total resistance of these two? We know that it is 10 ohms. And 10 by 10 is 1 ampere. So in this case also, the current is 1 ampere. So there is no change in the current. What about potential difference across the lamp? So we'll see here what is the potential difference across the lamp. We know that potential difference V is equal to IR. So current flowing through this is 1 ampere, and hence it is 1 ampere into resistance of the electric bulb is 5. So 1 into 5 is 5 volts. What about in the second case? The current flowing through this is again 1 ampere here, and resistance has not changed, so it is 5. So hence it will be 5 volts again. So there's no change in potential difference also. So then you might think, what happened when you added this 10 ohm resistor in parallel? Was there no change at all? No, there was a change. So what is the change is the current flowing through here is 1 ampere, And what about in this path? The current flowing through here will be again V by R. V is 10 volts also for this path. What is the R? R is also 10 ohms for this path. So hence a current of 1 ampere will also flow through this path. So 1 plus 1 is what? So in the main circuit, you will have a 2 ampere current. So this 2 ampere current will come and get split into 1 ampere, and then it will rejoin again as 2 ampere. So this is the change that happens in this circuit when you add this resistor in parallel. Hope you understood this solution. The important thing that you need to know is Ohm's law, how to calculate voltage given current and resistances. Hope you love this video. If you want me to solve any other questions, please put it in the comment box. I will definitely take it up in my next video. Thank you for watching.